welcome to Blue Pen Land. So again, let's do another one of these energy problems here, right? So this is a head-on collision, right? So I'm going to make this guy going to the right. I'll make this guy going to the left, and let's draw a picture of what this looks like. So let's go. Here's before and after, right? So I'm just going to draw. I've got the 160 gram, so 0.160 kilogram going 0.150. So I'm going to have this guy going this way, right? And then it's going to collide head-on with, what is it, 0.230. So don't forget to turn these grams into kilograms. Do that right away. And that is going to be going this way at 0.540, right? Now to make this to the left, I'm going to put a minus there, a plus there, right? Okay, so this is before, right? So this guy, let's have him go to the right, this guy go to the left, and then what is their post-collision speed? Okay, so here they are stuck together. So that's going to be 0.16 plus 0.23. That's going to be 0.39. Right, and then it's going to be going some velocity v. So let's figure this out. Let's go 0.16 times 0.15 plus 0.23. So I'm doing the devilry here is just m times v plus m times v equals m times v, right? Negative 0.54 equals 0.39 times v. Now don't round these numbers, okay? When you get these answers, don't round them, okay? Because yeah, you'll be off if you do the energies with rounded values. Okay, so here we go. So 0.16 times 0.15 plus 0.23 times negative 0.54. And I get that this velocity, this is an even velocity. The velocity is negative 0.1002 meters per second, which is not correct. Oh, because I haven't divided by 0.39. That's not the velocity. Okay, hold on. Now I have to divide by 0.39. Divided by 0.39. There we go. Okay, so the velocity is negative 0.256923 meters per second. There we go. Okay. Okay, so now I've got the velocity, right? And then it says how much energy is lost in the collision, so let's figure out the energy. Okay. So total energy before is 1/2 0.16 times 0.15 squared plus 1/2 0.23 times 0.54 squared. And don't you put that minus sign in there, it'll mess you up, okay? So I'm going to go 0.5 times 0.16 times 0.15 squared plus 0.5 times 0.23 times 0.54 squared. So this total energy is 0.035334 joules exactly. Okay, and then this energy is 1/2 0.39 times that number, right? 0.256923 squared, right? So let's figure that out. So 0.5 times 0.39 times, and then I'm going to use that number in my calculator. Okay, so I'm going to go up here to that. Pop that number in there, and I'm going to square it. And I put parentheses around it because when I pop it in there, it's negative. But if you put parentheses around it, the TI calculator will square it properly. And I get that this energy is 0.0128718,462, right? And then obviously the energy lost is this minus this. Okay, so I'm going to take this guy, and I'm going to subtract this guy to get the energy lost. So let's find that. There's this guy minus this guy. And I get that the energy lost is 0.022462 joules. Right? So again, that's this number minus this number is this number, right? So that's wrong. That's interesting. So there needs to be another 0 in there, right? Otherwise, I think we're right. Okay. That's interesting. Pretty sure that's right. Yeah, that's right. All right, there it is. There you go. Okay. So just set up your momentum equation, get that number, and then don't round that number. Okay. Don't round the velocity. Use the exact velocity. Use these guys unrounded. I just used the up arrow thing in my calculator and did the subtraction. It was pretty easy. You might consider, if you don't have the ability to go up arrow and pop the number in, you might try going stow alpha A, right? And what it'll do is it'll store that in a variable, and then you can subtract the variables. Just a suggestion.